Hi, my name is Brendan Tansey, and I'm part of the Stealthwatch Labs team here at Lanco. Today I'd like to talk a bit about Cryptolocker, what it is, how it works, and how best to protect your environment using Stealthwatch. So Cryptolocker hit big in the news, and it did for good reason. And that's because it's not what people typically imagine malware to be. Typically when people think of malware, they think about, things they don't see on their computer. They think it's there, but it's really sneaky. And with Cryptolocker, that's not really the case. Instead of quietly gaining a foothold and lying low, a Cryptolocker infection really makes itself noticeable to an end user who gets infected. And that's because upon a successful infection, a victim will see screens like these. And Cryptolocker doesn't try to hide its presence because it falls into a category of malware called ransomware. And ransomware doesn't try to hide itself because its goal is to almost directly confront its users to try to either threaten them or con them into sending money to the distributors of the malware. And Cryptolocker isn't the first type of this that we've seen before. A couple examples from the past are, for example, fake AV, fake antivirus. This was malware that went around and it would infect machines, and then it would present itself as if it was an antivirus product, and it would tell users for just a couple of bucks they could purchase this antivirus and it would remove the virus for them, when really it was just removing itself. And another type that we've seen a lot of are FBI notice malware. This might change your background and say, we're the FBI and we're investigating you for these computer crimes, and we can terminate the investigation early if you just send a couple $100 via MoneyPack or PayPal or Bitcoin to this address. And they're all threatening, and they do make a lot of money. But the thing about them is that a lot of types of ransomware can just be easily removed once found, and this often undoes the damage. And this is where Cryptolocker differs. Removing the malware doesn't actually undo the damage that it causes. And due to the type of damage it does, this makes Cryptolocker not just a huge threat to end users, but also the enterprises that those users work for. What Cryptolocker does is it uses encryption to lock many of the types of files that a victim might have on their computer, many of which are listed here. By limiting itself to these types of files, it'll leave your computer functional, but it aims to encrypt the files that you want back, or that you're willing to pay for to get back. For example, office documents like your Word documents or your slideshows, or photos you have on your computer, or encryption keys that you have. Anything that you're willing to pay to get back, really. And it also tries to encrypt files on any network shares that its victim's connected to. This means if you're at work or you're at the office and you're connected to a file server, it'll try to encrypt those files if it can. And again, this is what makes it really a pretty big threat to an enterprise network. Once the first set of files are encrypted, Cryptolocker demands a ransom to unlock them. But Cryptolocker is not the first piece of ransomware to behave this way, so what makes it so effective? For one, Cryptolocker uses Windows' built-in encryption. Many types of malware use encryption, but often they implement their own. The problem is that doing this properly is incredibly difficult. Malware analysts often aim to reverse engineer these cryptographic implementations due to those weaknesses. The thing is that Cryptolocker uses Windows' enhanced cryptography library to do the hard work for them. This greatly reduces the likeliness of finding those flaws. Beyond that, though, and more importantly, is the fact that Cryptolocker uses a mixture of symmetric and public key encryption. So often when people think about encryption or locking files, they're thinking of symmetric encryption. This means that the same key or password is used to encrypt and decrypt files. What makes Cryptolocker so formidable is its use of public key encryption. Public key encryption uses what's called a key pair instead of one key. And, public key encryption is quite the topic on its own. In short, one key is used to encrypt files and a different but related key is used to decrypt them. What makes this so effective for Cryptolocker is that an infected host can download an encryption key without ever actually seeing the decryption key. This means that the key to decrypt a victim's files never actually touches the victim's computer unless they've purchased it. This is part of what makes Cryptolocker dangerous, but it might also be a good way to fight it. The key pair is actually generated on the command and control host that Cryptolocker tries to reach out to, and that's something that can be really helpful for us going forward. Once malware gains a foothold on a system, often its next step is to reach out to its owners for commands. And this is called command and control traffic, or C2 or CNC. In the case of Cryptolocker, its initial C2 exchange is where it gets its encryption key, and it won't encrypt your files without that key. So figuring out that C2 channel can give a defender a huge edge. Traditionally, malware C2 uses a client-server model, just like your web browser might reach out to a web server, and Cryptolocker does the same thing. This means that the malware is burdened with finding its C2 servers. Many pieces of malware have hard-coded domains or IPs to try, but this can be a potential weakness for the malware because these are easily discovered by defenders. Once these indicators are found, malware command and control servers can either be seized or have domains sinkholed. So again, for a malware author, hard-coding C2 addresses can really be pretty problematic. So what Cryptolocker does is it uses what's called a domain generation algorithm, or a DGA. A DGA is an algorithm that can come up with domain names dynamically, but also deterministically. This makes them harder to find in a binary, but also makes the C2 infrastructure harder to take down. When a malware author puts a DGA in their malware, they keep a copy of the same code for themselves. This means that they know what domains their malware's DGA will produce at any given time and can register those domains accordingly. On the other hand, this means that if a defender discovers the DGA, the defender knows where the malware will try to go before the malware ever actually makes any requests. So at StealthWatch Labs, we reverse engineered Cryptolocker and extracted the DGA from ourselves. This diagram shows the flow of it. Using the date, Cryptolocker seeds a series of arithmetic operations to produce a hostname and then to choose a TLD, or top-level domain. If that generated domain is a valid host, Cryptolocker will use it as its C2 host. If it isn't, Cryptolocker will try again with an incremented key value. This happens until it finds one that works, or it tries all that it can for the day, in which case the malware will go to sleep for a little bit and then continue to try again. We've incorporated this algorithm with Slick, the threat feed that we offer to our customers. This adds a Cryptolocker host group which will detect any Cryptolocker communication to its command and control servers. With Cryptolocker, being able to react quickly is very important, because a quick reaction can save files on a victim's host, connected storage drives, or even prevent infection completely if quick enough. And this is where StealthWatch's mitigation functionality comes in. Using the StealthWatch system's mitigation functionality allows the security team to have StealthWatch react for them to save time. This gives you the best chance of turning that alert into a major saved hassle. So, I hope that was helpful. This is Brandon Tanzi from StealthWatch Labs. Thanks for watching.